So looking at this, we're going to describe our end behavior. Oh, let me make it so that it doesn't zoom in so my handwriting is good. So if I want to describe this left arrow, how do we write that? As x approaches negative infinity, my y approaches, for this left one, if it's going down, my y is approaching which one? Positive or negative? Negative infinity. And then similarly for my right arrow, we're going to say as x approaches positive infinity, meaning it goes to the right, my y approaches positive infinity. And then how many roots does this have? One. Trust yourself. It only has one solution, and it's right here. Our roots, remember roots also means solutions or zeros or x-intercepts. So this has one solution where x is 0. Okay? So, that's it for bell work today. Today we're going to start messing with our polynomials a little bit more. Yesterday we talked about the very most basic of polynomials, which was our monomial. Today we're going to start talking about other kinds of polynomials, which means we're going to need to see the order in which we like to write them. Which we have worked in standard form kind of stuff before. I'm going to put a couple on the whiteboard right here. So something like 2x plus 1, 3x squared minus 4x plus 7. Those are polynomials. We've worked with those kinds of polynomials before. But what we're going to do in order to call something a standard form, it means we need to have a rule for it. So the rule we have for our standard form for a polynomial is we are going to, I'm going to change that word. We're going to order the terms from biggest exponent to smallest. So it's all about the order of the exponents. And things like slope-intercept form or our standard form of a quadratic are already in that order. So we have x squared, then x, then no x. We have x, then no x. So 2, then 1, then 0, because I have no x's here. So from biggest exponents to smallest exponents. That's how we're going to line it up. So if we had something that had like a cube, we would put our 4x cubed plus 7x, and then squared would come next, plus 4x minus 23. I don't know. Making it up. 100% making that up. The important thing for our standard form is that our exponents go from biggest to smallest. Biggest to smallest on exponents. The degree of a polynomial is the degree of the biggest term. And when I say term, what I mean is each of these little chunks that's being added together is a term. So 3x squared is a term. 4x is a term. 7 is a term. 2x is a term. So we add up all the terms, and the degree is whatever our biggest exponent is. The degree, or actually, sorry, the largest degree of an individual term. So it doesn't matter if our polynomial is 4x cubed or if it's 4x cubed plus 7x plus 4x minus 3. This guy's still our biggest term, so it's still going to be a degree 3. Whether or not it has anything else after it, this one's going to be a degree 3. Just like a parabola is still a parabola whether it has other terms or not. This still has a degree of 2, even if it has other stuff. I wind up with ink all over my arms from this. And similarly, our leading coefficient is still going to be number, I can spell that right. The number in front of the largest degree term. So it doesn't matter what order we have things in. If it's not in a proper order, it's still our largest degree term. So our leading coefficient on this cubic that I made up here is going to be 4. The leading coefficient on this quadratic is 3. The leading coefficient on this linear binomial is 2. So it's the number in front of your largest degree term. And we are going to practice today with putting things into standard form and scooching stuff around to make it be the way we need it to be. And I'll give you guys a couple minutes to write this down because I know I've put a lot of words up there while explaining things. One thing I am going to point out that we didn't really talk about is we're going to be dealing with polynomials in one variable. So just x's, or just a, or just y. One variable. If we have more than one variable, it is not a polynomial. Just a couple more seconds to see a couple people still writing. Okay. So what we're going to do with these things here is we are going to identify our degree, identify our leading coefficient, and if we can, state our end behavior, just like we did yesterday. So what we're looking for, and I'm going to just zoom this one in so we can see it. There we go. So this is our first one. So this is a polynomial. There we go. So what we're looking for is which of these terms has our biggest exponent. Yeah, this guy is going to be our term that we're looking at here. 2x to the 4th. So what is our degree? 4. What is our leading coefficient? I'm going to write that out. So if I know it has a degree of 4 and a leading coefficient of positive 2, could we write out our end behavior? Yeah. Yep. Because a degree of 4 and a leading coefficient of 2, are we even or odd? Even. And are we positive or negative? Positive. So if we are even and positive, that means we have the same end behavior as a parabola, as a happy face parabola. So we can write out our end behavior for an even positive function by saying as x approaches negative infinity, my y approaches positive infinity, because my left arrow is going up. Then we're going to do the right arrow. As x approaches positive infinity, my y approaches positive infinity again, because my right arrow is also going up. So even if we know nothing else about this function, I can tell you where the arrows are going. I don't know what kind of wiggle squiggle craziness is going on in the middle, but I do know that both arrows point upwards. So then let's look at this next polynomial. I'm going to scooch this back over so we can see both of them. So let's look at this guy. We're going to look for our term that has the biggest exponent. Which term has our biggest exponent? Yeah. So this guy, my minus 7x cubed. So this is my term that we care about. This is our strongest term. This is the one that makes all the decisions. So what is our degree? 3. And what is our leading coefficient? -7. So watch out for the operations. That's where they're going to hide operations on you. If they put the negative out in front, it's really easy to spot that. If it's just minus 7x cubed, we have to know that that means it's a -7 as our leading coefficient. So that means we have an odd and negative function. So when we're looking to write out our end behavior, we have a negative odd, which means it has the same end behavior as a line that slopes downwards. Odds always act like lines. Negative would be our slope. So how could we write out the end behavior for that?
As x approaches negative infinity, y approaches positive infinity, as x approaches positive infinity, y approaches negative infinity.
Perfection. Perfection. Great job, Giovanni. And on this last one, I'm going to ask a slightly different question. Is it a polynomial? Is this something we can work with here?
No.
No. The problem here is the second letter. So this is not a polynomial. In one variable, which is what we're working with right now. It's not a polynomial in one variable, which means we're not going to be getting n behaviors on this thing anyway. We're never going to graph something in two variables polynomials-wise because they get horrendous. So we may work with them when we get over to some solving stuff a little bit, but for the most part, no. Yes, sir.
So if it was 4x squared, y squared minus 5, it would be a polynomial, or no?
If it it is a polynomial, just not something we're ever going to find n behavior for, because when it's in two variables, it no longer follows the n behavior rules the right way. So if I'm asking you for n behavior, that's not going to be it. Our degree is not going to be like a normal thing that we figure out. We could see our leading coefficient. What is our leading coefficient here? 4. But the degree on a multi-term polynomial is weird. So we're not going to play around with those too much. So we're just going to say that that's not a polynomial in one variable. And we're going to go from there. When that comes around with our solving stuff, I'll show you what we can do with it, but there's not going to be a whole lot. Yes, sir.
So would that be in the test? And if it is, how will we answer? Just put not polynomial? Right?
Yeah, that it's not a polynomial in one variable. I won't ask you the degree on something like that. I won't. Okay, so the next thing we're going to practice is the standard form thing. Putting these things in standard form, because sometimes they're not going to give it to us in standard form, and it would be helpful if we could do that. So I'm going to zoom it in here. So we're going to work on this guy first. We have 3x squared minus 7x cubed plus 2x to the fifth plus 2x minus 3. And we want to put this in standard form. So write this whole thing down. I just went on the test to double check. We will not ask you about more than one variable. We won't have it on there. Just something I wanted to bring up. Okay. So what we're going to do to put this in our standard form is we're going to rearrange this so my exponents go biggest to smallest. So what is my biggest exponent here? Yeah, the 2x to the fifth, 2x5. So that's going to be our front term, 2x to the fifth. What is my next biggest term? Yeah, but we have to be really, really careful because this is actually a minus 7x cubed. So minus 7x cubed. What's my next biggest exponent? the 3x squared. What operation is going to go in between my 7x cubed and my 3x squared? Addition. Because there's not a sign in front of the 3x squared that we can pull with it, so we have to know if there's not something written there, it's an assumed positive. All right, what's my next smallest term? The 2x. So then we're going to have our plus 2x. And then we'll end it off with our last one, the one that has no x, minus 3. Oh, look, we made a pretty rainbow. That was entirely accidental, but I like it. So all it means to put something in standard form is to write it from biggest to smallest exponents. So I'm counting down. 5, we skipped 4, we don't have a 4 here. 5, 3, 2, 1, 0. So then we're going to practice that on behavior again. So what is our degree for this polynomial? It's going to be the 5. So we see where we're headed with it, but flip the word. So our degree is that exponent. So then what's our leading coefficient? 2. So our leading coefficient is 2 and our degree is 5. So is this one even or odd? Odd. Good. And are we positive or negative? Positive. So odd and positive, that's how we figure out our end behavior. Odds act like lines. So positives give us positive slope. So this will have all kinds of wiggles, squiggles in the middle, but it'll have the same arrows as a line. So we're going to write out our end behavior here just to practice writing this. As x approaches negative infinity, y approaches what? Negative infinity. And as x approaches positive infinity, y approaches positive infinity. Good. All right, we're going to practice that again. We're going to put it into standard form, identify our degree, and our end behavior. So here's our next one. So we have 2 minus 7x cubed plus 2x. Apparently I was in a 7 mood lately. We've had a 7 in every single problem today. So what is our first term going to be? Negative 7x cubed. We've had negative 7 be a term, I think, in every single one of these. I was apparently in a negative 7 mood. So that's our first term, but what's our second term? The plus 2x, which means this guy's going to close with plus 2. So we get this down to a trinomial. What is our degree? 3. Our biggest exponent. And what is our leading coefficient? Negative 7. So here we have an odd and negative. I don't know why I did that instead of the sign like I've done for all the others. So odd and negative, which means it has the same end behavior as a downward sloping line. So we can write out our end behavior. This is the last end behavior we're going to write today. As x approaches negative infinity, y approaches positive infinity, because my left arrow is going up. And then as x approaches positive infinity, y approaches negative infinity. Good. So I'm going to give you a second to write that down, but that's the majority of what we're doing today, and the majority of what's on the back of the worksheet. And our last thing is going to kind of combine with the second question on the bell work with what we're doing here. Ew, C was mean on me. We're not going to be doing like a ton with this, so I didn't print these graphs out for you. Probably should have, but I didn't. So what we're going to do is we're going to figure out how many roots each of these has, what might be our degree, and where are our extrema. So give yourself a little sketch of this. The values themselves don't matter, but just a little squiggle sketch. Because how many roots, how many zeros does this one have? 6. Remember, our roots are where it crosses our x-axis. So we have 1, 2, 3. So this has 3 real roots. Looking at our end behavior, is this going to be an even degree or an odd degree function? Odd. So we know this is odd, and it has 3 real roots, which means our degree has to be 3 or bigger, and it's going to be odd. The number of real solutions we have, it has to have a degree at least that big. So this could not be a linear function. This could not be just x to the first, because I can't have 3 solutions for x to the first. This could not be x squared. I can't have 3 solutions when it's x squared. So this has 3 real roots and it's odd, which means our degree is 3 or bigger. And odd. And then just as a real quick refresh, does this one have an absolute maximum? No. Does it have a relative maximum?
Yes.
Yes. This guy right here is a relative maximum. Does this have an absolute minimum?
No.
Does it have a relative minimum?
Yes.
Yes. Right here. Odd functions are never going to have absolute extrema because it's got those opposite ends. We're going to do the same thing on the right. That's all we're doing with these. Is how many roots? What does that tell us about the degree? So how many real roots does this right one, the W-shaped one, have? 4. 1, 2, 3, 4. 4 roots. Is this going to be an even function or an odd function?
Even.
How can we tell? Yeah, because they match. So like even functions, think about parabolas. Both ends go together. Both ends go together. If both ends go together, it's going to be an even function, which means my degrees could be 2, 4, 6, 8, 10, blah, 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 blah. Could this one be an x squared? Have we ever drawn a parabola that looks like that? Because I can't have 4 solutions when it's x squared. The number of solutions cannot be bigger than your degree. So our degree is 4 or higher, 4 or more. It could be that this has x to the 6th, could be x to the 8th. It could have things that are wiggly squiggly elsewhere. More than likely it's an x to the 4th. But we don't know without an equation. But we do know it's going to be even. And we do know that it has 4 roots. On the worksheet, all you're doing is telling me how many zeros it is. You don't have to go into the even versus odd or what degree it could be. You're just going to be saying how many real zeros it has. Okay, but I just wanted to cover why we care. Yes, dear? Because the number of solutions we have has to be at least the degree number. I cannot have 4 solutions if my degree is 3, or if my degree is 2. It doesn't have to be an x to the 4th. More than likely it is. But it doesn't have to be. Okay, so we're going to be getting firmly into our polynomial stuff from here on out. We have almost 10 minutes until announcements, and that is the end of what we have today. Okay, so we are going to be doing our chapter test on Thursday, November 16th. We're going to be doing a really short skills check on Canvas on Friday. So you're going to need your computers because it's on Canvas. So I'm just giving you the warning now. It's a multiple choice kind of situation. Some of us needed a little boost to that assessment category, so this should help with that. Okay, so Friday we're going to do a short skills check. But you guys have the rest of today. You can do the backside of homework 4.1. Be careful on 3C, is what I'm going to say.